Hiya. So this PowerPoint is going to go through some revision techniques for when you're revising quantitative chemistry. So the aim of this is to show a set of skills on how you can tackle these calculation questions. It can be a bit tricky, but hopefully by the end of this little session it will give you the confidence to get full marks when you tackle quantitative chemistry in your exam paper. First things first, when we talk about quantitative chemistry, you need to be aware of where it lies in the specification, whether you're taking combined, higher or separate chemistry. So I've highlighted here. So anything that's in the brackets is higher tier. So if you're taking higher, then you are going to be tested in these areas. The one highlighted in red is for all areas, whether you're doing combined, separate and higher. And the purple section here, 4.3.3, is for those who are taking separate sciences. So you will have all of these, including the ones highlighted in purple. If in doubt, do go on the AQA website and have a look at the specification. So quantitative chemistry can be a bit daunting. It is testing basically your math skills. The reason why you need to learn about quantitative chemistry is because well, in chemistry you're learning about atoms, and we know that atoms, molecules and compounds, they're incredibly small, really, really small, and you have thousands, billions of atoms that we as chemists we are working with. So we use a mathematical formula to help measure the amount of substances that we need when we go through a chemical reaction. Now, when you do your revision for quantitative chemistry, it's really important that you learn your formulas. So, an example could be getting all your formulas out like I've done so in this PowerPoint slide as a formula triangle, put it on a poster, put it on your cue cards, but it should be nice and clear when you display this on your walls or on your revision cards. Now, if you look here, I'm a big fan of the formula triangles because I think they're super easy to use, and also when it comes to rearranging equations, they're nice and simple. So if we look at this area here, when you're looking at the formula for working out moles and concentration, let's say for example I'm working out concentration, you cover up concentration and then be moles divided by volume. If you want to work out moles, if you look where my arrow is, you cover up moles and it's be concentration times volume. So these are the main formula triangles that you need to use. Right, so let's go through an exam question. Now, just to let you know, when it comes to quantitative chemistry, most of the exam questions on this section are normally between 9 and 14 marks. So it's quite a big section. So I'm going to give you the skills and techniques of how to tackle these questions. The first one here, nice and easy, just recalling what is meant by a strong acid. So they've given you the chemical equation, neutralization between an alkali and an acid. It says sulfuric acid is a strong acid. What is meant by a strong acid? And the last section here for part 1A and B says write an ionic equation, so showing ions, including state symbols. So then, strong acids fully dissociate in water. I've highlighted what is required to write for the 2 marks. You get 1 mark for saying dissociate, 1 mark for saying, 1 mark for saying fully dissociate, and the 2nd mark for saying in water. And if you were to compare it to weak acids, just remind yourself that weak acids, they don't, or they partially dissociate in water. So this is just recalling your knowledge on the definitions of a strong and a weak acid. So if you look at the mark scheme here, I've highlighted where the marks are rewarded. So we've got 2 marks. You must mention the word fully ionized or completely ionized and in water. The second part is showing your ionic equation, which is about your ions. So you've got your H+, and this is actually the species that determines whether you've got acid, a strong or weak acid is the H+, it's the protons. So here you've got the equation which is correct and balanced, and the 2nd mark goes for your state symbols. Okay, and that is actually mentioned in the question. It says do include your state symbols, that's your 2 marks. Right, now we're going to come to the mathematical side of it. Now, when I was looking at past exam questions, when it comes to quantitative chemistry, they do like to test you on titration. So I do strongly advise you to go through the method of titration and familiarise yourself with the sequences of that, because that can vary between 4 or 6 marks. And it also links in with one of your required practicals. Now, when you get a question like this, please remember rule number 1, do start highlighting or underlining the key points. Now, a question like this, you've got values for a reason. So every single time you see a value, underline it. Also, you must look at the key terminology they're using here. So describe how the student will complete titration. So you're going to talk about each step, and also within that you need to include a suitable indicator, give the colour change. They're giving you instructions of how you should display your answer. It's really important. So my advice to you is every single exam question that you come across, underline the keywords, the values and the keywords. Find out exactly what is it you need to do. So this, you need to memorize your indicators. So these are the three main ones you need to know. When it comes to revision, put it in a table like this, because you can have clearly, it just represents what indicators, the three main ones, and also the colour changes. And you write it in a different colour so it helps with your revision and long-term memory. So something like this also helped me when I was doing my revision when it came to titration. Draw it out. When you look at methods, sometimes it can be quite overwhelming. So I used to use pictures, and they helped me a lot with my long-term memory. But this question here, you're only going to be talking about the process between B and D. Yeah, so we're not going to talk about A, we're talking process between B and D. So it's the concept of, right, you've got your solution there, you're putting it into the conical flask, adding an indicator, and when you titrate that against another solution, what happens? What do you expect to see, and the colour change? Right, so here's where you're going to get the full marks. So first of all, you talk about the indicator. Now remember, the exam question says to you, mention a suitable indicator and the colour change. So any of these can be added. And remember, that is taken from the revision slide that I showed you earlier about the table of different types of indicators and colour changes. Do not accept universal indicators. That's one you should not mention. Right, next one. You add in the acid from the burette. So you need to mention the apparatus of the burette, which is that long cylinder. Then you swirl it around until you get an end point or the colour changes. And then the bonus one for the fourth mark, you need to indicate the colour change, okay? This is normally, when they talk about titration 4 marks, this repeats itself quite a lot in the mark scheme. So familiarise yourself with the method and include the key points that's highlighted on this PowerPoint. Right, next one. So when it comes to titration again, they like to give you a set of results. And the first skill that they normally test you on is working out the mean volume. And they like to use this word here, concordant results. So they're giving an indication of giving you an idea of what concordant results mean. Now, same thing, I've highlighted the key things. So I've highlighted this section here. Use the student's concordant results to work out the mean volume. So this question is saying to you is, using any set of data that lies within this range, work out the mean volume. Do not use all of them. Now, I've highlighted this area here, not because these are the concordant results, but just to show you how many significant figures are included after the decimal point. And it's really important because when you write down your answer should match up to the same amount of significant figures they mention in the table. This is a skill that we also teach at A-level chemists. So, according to, if you were to look at the concordant, look at the range, which ones lie between this range of 0.1, titration 3, 4 and 5. Okay, so these three lie within this range here, so all you do is add them together and divide it by 3. Now, if you look at the mark scheme, that's exactly what they've done here, and your answer would be 27.12. Do you notice how many significant figures I have? And it also matches up to the values that have been placed in the table results as well. It's the same, it's consistent. An easy 2 marks. Right, this is where it gets slightly lengthier. So I've got 4 marks for this. Look at the equation and you're going to calculate the concentration. Again, I have highlighted the key words. Look at this one here as well. Give your answer to 3 significant figures. Because what happens is that sometimes when you're in a rush or you're under the pressure of the exam and the time, you forget what the question's asking you. So you write down the answer quickly and you actually don't get the full marks because you don't go back to actually double check to see whether you answered what the examiner wants you to answer. So this is a good little checklist. So after you've done your answer, go back to what you've highlighted and make sure you covered all the main points. So it's time to calculate the concentration. Now, the first thing that I would do is to get my formula triangle, make sure you've got the correct one. So concentration, I'm expected to be using this formula triangle here. Okay. Here is a good step guide on how to do titration calculations. Now, I'm not going to go through this in detail, But I would strongly advise you to write this out and stick this on your wall or have it on your cue cards or your revision cards, because this is really, really good in terms of making sure you're covering all the areas when you do titration calculations. These tend to be 4 to 5 marks. Right, so the equation for the reaction is given above. Calculate the concentration, 3 significant figures. Now, the easiest way to do this is, number one, I would write this in the exam. So when I'm doing my calculation, I'm referring back to my formula triangle. And also, read the previous part of the question. Is there any information you can use, right? Of course there is. There's loads of stuff. And that's the biggest hint. This question here has different parts, A, B, C, D, E, etc. They've given you values in the previous question that you must use. And what do I mean by that? So if we looked at the previous question when you worked out the mean volume, there's a reason why you had to work out the mean volume, and that's your reason behind it, because you can actually use that figure there. So if you go back to the original question at the top, part C, they're giving you values. There's a reason why they're giving you these values, because you're going to be using them from 25 and 0.1. So my tip is this: when you have a titration question, go back to the start of the question and look at the values they've already given you. The next thing I would like you to do is put yourself a table. Now this table is fantastic. This is a really good way of visually inputting the data that you've already got or have been given, and you can look at the gaps, and the gaps in this table tells you what you're going to be working out. So remember, let's go back to the question. Calculate the concentration of sodium hydroxide. There is sodium hydroxide. There's my question mark. This is what we're aiming to find out. All the other values have actually come from the previous part of the question. So there's my little triangle up there. So 27.12 is what we previously worked out for our mean volume. 0.1 was given at the exam question. I think it was either part A or B. And also this value here was also given. Have you noticed that when your volume is given in centimetre cube, you must convert it in dm3, and you do that by dividing by 1,000. So everything I've highlighted here, my stars, they have either you've worked it out previously or they've been given in the exam question. So it's very important to put that data in. And just by filling that table, you can see visually what is it you're required to work out. So here I'm missing my moles and I'm missing my concentration. This is the last part that we're going to be focusing on. Right, okay, so moles. If I go back over here, if I cover up moles, moles is concentration times volume. So you're literally just putting in the information from here. So I've got my concentration and my volume, times them together to give you your moles. Remember, your volume is in dm3. So I've worked out my moles for H2SO4. Now, think about it. I've got my moles, I've got my concentration volume from H2SO4, which is fantastic, but I've still got gaps on this side for my alkali. So the next stage I need to do is move across and work out my moles. Now, when you work out the moles, you must go back to this original equation here, because this equation here shows you the ratio, and you must factor in the ratio of your substances. Is really, really important. So if I said that the moles for my H2SO4 was 0.00271, look at your ratio. It's a 2-to-1 ratio. So what you're expected to do is, with that value, is to times it by 2, because for 1 mole you've got 0.00271, but if I want to calculate it for 2 moles of the alkali, I need to times that value by 2. Yeah. So the moles of H2SO4 times, but that's why it's so important to go back to this main equation here. Now, can you see how my table is looking nice and healthy? We've got all the areas filled up, apart from my last section here was concentration. Go back to my formula triangle. Concentration is moles divided by volume. I can now do my moles divided by my volume in dm3. And your answer would be 0.00542 divided by 0.025 to give you your answers here. Now, have you noticed the difference between what is highlighted in purple and what is in black? The reason why I've written out there, because you're doing it to 3 significant figures. Go back to what you've highlighted previously in the question. So the first mark goes for this section here when we work at the moles. The second mark goes for the moles of NaOH. Third mark goes for this value here, and the bonus mark is 3 significant figures. So my tips for you is this: when it comes to titration questions, draw this table out, and also look at the step-by-step guide I've given you in the previous slide. There's 4 steps on how to work out titration calculations. So this question here is a really good question. It's 2 marks, but I reckon I'll say probably stretch and challenge question, because you're required to actually use 2 different formula triangles for this. The student did another experiment using 20 centimetre cubed of sodium hydroxide. Straight away I'm going to underline that, with a concentration of 0.18. So I'll underline that value as well. They're giving you relative formula mass, and they're asking to calculate the mass. Now, this can be a little bit confusing because they're giving me values in centimetre cubed and concentration, so I would expect to use this triangle here. However, it's asking to work out the mass, so you also need to be using this triangle here. So there's 2 different formula triangles. We want to work out the mass. Now think about what we've got so far. I need to work out mass. I've got my relative formula mass there, which is 40. And I need to, as you can see in front of you, I've put the question mark on mass. So that's what I need to work out. The only thing that's outstanding is moles. Now, I cannot work out the moles because I've got no mass, so I cannot use this formula triangle. This is where I need to move on to my red triangle to work out my moles. Because if we look at the exam question, they've given me the volume, which is 20 centimetre cubed divided by 1,000. They're giving me concentration, which is 0.18. So I'm required to use the red formula triangle to work out the moles. And then, once I've worked out the moles, I'm going to move on to the blue formula triangle to work out the mass. Good question. So, I am going to do 20 divided by 1,000 to convert it into DM3 times by, there we go, to give you number of moles. So my moles worked out to be 0.15. I'm then going to times it by 40, which is my relative formula mass, to give me my mass of 0.144. So, coming to the end of this revision video on quantitative chemistry, I do hope you find it useful. Go back to it, go back to the first slide and go through the video again to make sure you establish the key points and how to tackle these questions on quantitative chemistry. Top tips. Practice makes perfect. Go through as many questions as you can so you master those skills. Go through this calculation and find a similar question to complete. This has always been a really good tip that I've shared with all my students. If you're revising quantitative, you do an exam question, then mark it, then find a similar exam question and keep going through that routine, and you see that not only do you develop your long-term memory, but you really do emphasise and enhance those skills on how to tackle the titration questions. Ask your teacher for additional exam questions and resources. We are here to help you, so if you need any additional resources, we can upload it for you or pass it on. So good luck, and you'll be experts by the end of this video.